Hello everyone, this is Manish Narayan from Dayananda Sagar College of Engineering. This is our project video. Our team consists of three members, Manish, Chintan and Kaushik. Our final year project title is Text Detection and Recognition in Natural Scene Images. So we have divided our project implementation into two parts. One will be text detection and then we will do text recognition. So at first, text detection is done by having bounding boxes across the image, uh, across the text in the image. So for every text, we have a separate box. So for every word, we have one separate box. And then this text detection is done by a deep learning model, which uses layers of convolutional neural network. And it has been trained on a data set called ICDIR. And every 2 years, ICDIR releases a new data set. So we have trained it on ICDIR 2015 and 2017 together. So after this, each of these boxes has to be sent to another model which can recognize the letters inside this as a single word as text. And for that, we are using an OCR model called Pytesseract. It's also another neural network engine which has an LSTM engine inside it. So LSTM is a long short-term memory engine, and it is of recurrent neural networks. So you can see we'll get a text file out of this. So for the same image, you can see that we are getting the text. So we're getting the Dayananda Sagar College of Engineering and Department of Information Science. So this will be the two final outputs from our project. And next, I'll show you the implementation part. So as you can see, we have done it on an Ubuntu machine. And also we have used a Docker. So a Docker will be similar to a virtual environment where all the required libraries have been installed in that. And so we are using TensorFlow, OpenCV, Python, and Pytesseract as our different libraries. So first we'll have to run the Docker. And once we're inside, we can navigate into our folders and then run the file that we need to test our model. So first, we'll go to our text detection and TensorFlow directory. So once there, we can run a file called eval.py, which will evaluate our model based on the images that we provided. And we are giving it an argument called, so this is the folder which will have all the different images that we need to evaluate on. So we will see this folder now. So this is called test folder. So it has 8 different images on which we will evaluate our model on. So you can see that these are all different kinds of text and these are in natural scene images. So that is one of our project lines in our title. So, and you can see this is one of the photos that was taken in our college. So in the command line, we'll see that first we get some debug messages, but after that, you can see that it is printing for that image. It is printing the original dimensions and the resized dimensions for that image. So for example, open.jpg, it was 289 cross 500 and then it becomes 512 to 320. So we need to resize the image so that we can run it on the model. And once it's detected, it will be stored. The detected image will be stored in one folder and the detected text will be stored as a txt file in another folder. So now you can see the Python code. So this is our eval.py folder file, and we're doing the text recognition and detection through this. So I will see if This is done. So for each image it has to run and it is printing, as you can see, whatever was in the text file, it's already printing here also. And now again we can see the output. So first is the text detection output, which is stored here, and it's still updating, but you can see one of the images one by one. So here you can see all five words are detected and there's a bounding box across them. And here was one of the very low 240 pixel image, so for that it does not work, but otherwise it still detects everything. So even in this you can see that all the words are detected, and even in the next one you can see even though this thing is slightly curved, it's still detected. And these are the easier ones. So this is the detection output. So once we can see that this is done, we'll also look at the output of the recognition model. That will be in this folder. And you can see it has different text files, txt files for each of them. So if you want to see one of those examples which had Caputo's bake shop, and at the same time, which is a simpler one, it just prints oh, okay. And the hardened one, which we already saw, was a lot of text here, and each of them is recognized and printed. So at the same time, two more things that we needed to work on for our model to make our model better than the ones that already existed were one, we had to add blur, try to see if it works on blurred images also, and then work on the curved text. So there will be some images in natural scenery where the text is actually curved. So like this, which we saw, this part of the text is curved, but then at that time, the detection models will not be able to detect it properly because of the curve. So in from our model, as we showed, it can still detect properly. It can put the bounding box and then perform the recognition also. So the second part was blurred images. So for blur, I have added Gaussian blur to all of these images that we already ran. So in our code only, I've purposefully added Gaussian blur with a 15 cross 15 kernel. So Gaussian blur is basically averaging out all the adjacent pixels for each pixel. So you're saying so 15 cross 15 kernel means you're taking a 15 cross 15 pixels with that pixel as the center, and then you're averaging it out. So basically there will be a lot of blur in your image. So you can see here, so the actual one the model saw was this. You can see there's so much blur in this, even in this, even here. And one of these is just like it, you just cannot see anything in this because it was already 240 pixels. But since we added blur, this is why our model was not able to recognize anything. So first, now we have established that it works on curved text, and it also works on so curved text. You can see you'll get the proper boxes for it, and we also established that it works on blurred images also, except for some cases where it is very bad. So very small 240 pixel image, but with added blur you cannot see anything. So now we will check if we remove the blur for that image, if it works or not. So now I'll just comment out this one line where I added the Gaussian blur, and so once I save it and run it again, we will just run on that one particular image, see if it makes any difference. Then you can see that now you can see I just have in this folder, low folder, I just have this one image which is just of to 40 pixels, and then you can see this. And then with if we added blur, it was not detecting anything. So now we'll just remove the blur and try it alone. So again, it'll first show some debug messages from TensorFlow and Matplotlib, so you can see debug. And then after this, we will get the actual dimensions of the image and the resize dimensions. And after that, you can see what it recognized and detected. So basically, the outputs from our project are two things. One is the detected image with all the bounding boxes. For every image that we run it on in the folder, it will create another image, a copy of that, and put all the bounding boxes wherever the text it has detected. And the second one is with the recognition. So it will create a txt file and in order. So you can see this time. So you can see this time the detection has happened for this blurred low pixel image. So even though it's not perfect, you can see it's still detected warning and the smaller boxes that it has created. At the same time, one of our outputs is the text file. So warning detected, low flying, blast, whatever those three words were already present in that image. So this is our final year project, and these are the two things, two outputs. Thank you.